Hello. So welcome you all to the introduction to database management system. Myself Dr. Anisha Mukherjee. These are my contents. Now what is DBMS? A database management system is a collection of interrelated data and a set of programs to access those data. The collection of data is referred as database. The primary goal of database management system is to provide a convenient way and efficient way to store and retrieve database information. Now the data which is meaningful, which is processed, that is referred as information. So the primary goal of database management system is to provide a convenient and efficient way to store and retrieve the database information. The collection of data is referred as the database, and database management system, or in short DBMS, is a collection of interrelated data. Now what is interrelated data? Let's take an example. Suppose you are a student. You have an ID, you study in a particular department, you have a name. So these are all related data. So interrelated data. And to access the data, you need a set of programs. So the DBMS is a collection of interrelated data and a set of programs to access those data. Okay. Now there are a lot of real life applications of database management system. For example, airline reservation system, railway reservation system, student database management system, banking sector. We also have databases, universities where to maintain student information. Another one is the library management system. In sales also like to maintain the customer information, product information, purchase information. So in sales also we have the applications of database management system. Okay, now why DBMS? To store data, you have files. Now what are the disadvantages of file processing system? Now before going to this, here one thing I need to mention, that there will get some points, terms like isolation, atomicity, concurrent access. So these things will be clear to you when I will discuss the topic transaction. I will discuss ACID properties. So then these terms will be clear. So for this time, you just look into the disadvantages that I am discussing now. Data redundancy means redundant data and inconsistency. Now to take an example of inconsistency, suppose that you have scored 85% in an exam. Now after your score has increased to 89%. Now suppose in a place it is written as XYZ has scored 85%. Semester 1. XYZ has scored 89% in semester 1. Now this is inconsistent. In one place it is written as 85%, in another place it is 89%. So which one is the correct one? So that is an example of data inconsistency. Difficulty in accessing data, another point. Data isolation, integrity problems, atomicity problems, concurrent access anomalies, and security. So these are the disadvantages of file processing system. Now look at the history. In 1950s and early 1960s, magnetic tapes. Late 1960s and 1970s, the hard disks. These are to store data. Okay. In 1980s, relational database. Early 1990s, SQL. Late 1990s, revolution in DBMS. Why? For the explosive growth of what? WWW, World Wide Web. Early 2006, query comes with the extensible markup language, that is XML. Now look into this picture. Magnetic tapes, then optical disc, then magnetic disc, then flash memory, then main memory, then cache. Which one is the first test? Obviously cache. And which has the maximum size? Magnetic tapes. Okay. Now what is the view of data? Now before going to the view of data, just look at this picture. At the bottom level we have physical level, and then in the next level we have logical level, and the top we have view level. Okay. So this physical level actually deals with how the data are stored. That is the lowest level of abstraction. In the next level, we have logical level. What the data are stored and what are the relationships among those data. And the part of the database that actually referred by the view level. Okay, so to provide user with an abstract view of the data, we have this 3-level design: physical level of abstraction, Lowest level of abstraction, how the data are actually stored, describes complex low-level data structure in detail. Next level, we have the logical level of abstraction. Next high level of abstraction, what the data is stored and what are the relationships among them. View level of abstraction, that is the highest level of abstraction that describes only part of the entire database. So this is very important. The 3-level architecture or sometimes 3-level design, 3-level schema. So these type of questions comes in the exam. Now what is an instance? The collection of information stored in the database at a particular moment, that is the instance of the database. The overall design of the database is referred as schema. Physical schema describes the database design at physical level. Logical schema describes the database design at the logical level. Now there are different type of database models: hierarchical model, network model and relational model. In hierarchical model, the data are organized in a tree-like structure. Now look at this picture. Department. Let we have 3 entities. One is department that has attributes DID and DNAME. Department ID and department name. Course, another entity which has course ID, course name, DID. That is department ID. That is CID, CNAME and DID. Student is another entity. Student ID, student name, department ID. Referred by SID, SNAME, but denoted by SID, SNAME and DID. Okay. So here which one is the root? Department. It has 2 children. One is course, another is student. So the data are organized in a tree-like structure. The data are stored as records which are connected to each other through links. A record is nothing but a collection of fields. Each field contains only one value. Each entity has only one parent but can have several children. At the top of the hierarchy, there is only one entity which is called the root. Next one is the network model, which is a flexible way of representing objects and their relationships. Viewed as a graph where object types are nodes and relationship types are arcs. Entities are organized in a graph. Some entities can be accessed through several paths. Look at this picture. Course is connected to student as well as department. Department is connected to course as well as student. Student is connected to course as well as department. So you can see this is a graph-like structure. Okay. Now we have relational model. An approach to manage data using a structure and a language. Data are organized in 2-dimensional tables called the relations. The tables, that is relations, are related to each other. So here we have student, department and course. Students study in a particular department. So this is the relation. Course, department runs these courses. So this is another relation. So here the data are stored in tables. Each row is referred as tuple, or you can say record also, because in each tuple you are maintaining the record of a student. So sometimes it is referred as, each row can be referred as record, as well as usually it is referred as tuple. Okay. And the columns are referred as the attributes, or rather I can say the columns represents the attributes. Okay. Now what is data dictionary? A file or a set of files containing a database's metadata. What is metadata? Data about data. For example, author of a book, publisher name, date, etc. are the information or data about the book. So these are the this is actually metadata. So a file or set of files containing a database's metadata. It contains records about other objects in the database, such as data ownership, relationships to other objects, etc. A person who has the central control over the system is the database administrator. Now another 3 important topics: DDL, DML and DCL. Data definition language, DDL. It provides comments for defining relation schemas, deleting relations and modifying relation schemas. Data manipulation language or DML provides the ability to query information from the database and to insert tuples into, delete tuples from the database and modify tuples in the database. Data control language or DCL used to control access to the data stored in a database. For example, the command comment. So I have created one animated video for you. So this is the link to the animated video. Thought is the wind, knowledge the sail and mankind the vessel. So in my next class, I will discuss about I will discuss on the RIAD diagram, interrelationship diagram. I have shared links to few e-texts, e-contents. So you can go through those links. You can just study those materials and then attend my next class on interrelationship diagram. Okay. So it will be convenient for you also then. So thank you. Stay safe and healthy.